Hi everyone, today we are going to review using VMware's vSphere to virtualize both Macs and other available microservers. My name is Megan Zemansky, I'm the product manager for Addo Technology Thunderbolt adapters, and today we are also joined by Addo customer engineer Eric Garrison.
Hello.
The key topics for today that we're going to go over are: what is a microserver? What are key examples of them? What solutions can be used for connectivity using Addo ThunderLink adapters? And then we're going to go over some key virtualization use cases. But first, to give a little background on who Addo is as a company, we recently celebrated our 30-year anniversary, and what we're best known for is our extensive history in providing storage and network connectivity. We also have a very deep protocol expertise, which ranges from more established technologies, such as Fiber Channel, to some of the latest technologies that are out there, such as NVMe. Here you can see on the screen our entire product portfolio. While we ultimately deliver hardware products at Addo, you can also think of us as a software company because we do a lot of development with our software elements, which are going to maximize performance of those final hardware products. But for the solution today of these products, we are primarily going to focus on Addo's Thunderbolt adapters. And to start off the solution, we need to look at what a microserver is. So a microserver is a smaller form factor server designed for both ease of installation and maintenance, along with added benefit of low power and space consumption. Microservers are continuing to grow in popularity, and some specific options that are out there in the market are Apple's Mac Pro and Mac Mini, and then also Intel's NUC. And I'm going to pass to talk a little bit more about these platforms.
Thank you very much, Megan. So as we talk about these microservers, probably the one that's most used and most familiar with people is the Intel NUC as an R&D form factor, but the one platform that is rising the fastest and is developing the most need is virtualizing Mac OS, which requires the Apple hardware platform. So we're going to talk specifically about two devices that can be virtualized, that currently are being virtualized by the vast majority of people looking to do Apple and Mac OS virtualization, the Mac Pro 6.1 and the pre-November 2018 Mac Mini. So with the Mac Pro 6.1, we have a lot of advantages. It's fairly small, it's got a robust CPU, it's got a very good I/O bus, low power consumption, a fairly good amount of RAM, and as in almost any virtualized host, you can run any operating system on it. It is, in essence, an Intel server. Some of the things to take into consideration: it only comes with one hard drive. It has the 4 USB ports, the 6 Thunderbolt 2 ports across 3 Thunderbolt buses, and it also has HDMI graphics and comes with a pair of 1 gigabit ports. What it lacks is a PCIe slot, which is where it comes in. We'll talk about that shortly. With the Mac Mini, even smaller than the Mac Pro, same advantages, a little bit lower power on the CPU, a little bit lower of a maximum on the RAM. Again, we've got Thunderbolt 2 ports on this, HDMI graphics, and built-in gigabit management ports. With the NUC, these are constantly evolving and changing. The best way of figuring out whether or not a NUC can be virtualized is to do some Google searching. A lot of the motherboard specs are able to be virtualized, and you can look it up by that. Most of them come with 1, maybe 2 PCIe slots on board, and some of them come with Thunderbolt 2 and Thunderbolt 3 ports. So the biggest question, and in the last couple of years we've been presenting this topic, why on earth would I want to virtualize a Mac? Most people understand the reasons for virtualizing something like a NUC or a small server, kind of a quote-unquote throwaway server, because it's good for R&D. That tends to be the biggest reason why people have smaller labs or test labs in their work environment, because they've got to do R&D. We've got to test and validate that making this change is not going to negatively impact our environment. But when it comes to Macs, it really comes down to a couple of different options. And the biggest one that surprised us the most was corporate mandate. Corporate security mandate says no hardware is going to walk out this door. We don't want to risk our intellectual property being stolen because a laptop got stolen or it got hacked. The other reason is that only Apple hardware can run the Mac OS. With that said, most people just don't know that they can virtualize Apple hardware. But again, it's nothing more than an Intel server, so as long as the drivers work for the motherboard, it can be virtualized. And both the Mac Mini and the Mac Pro 6.1 platform have been successfully virtualized. So again, talking about these reasons for virtualizing a Mac: corporate mandate, budget constraints. You've got this hardware. You may or may not be using it as active desktops or laptops. You've got the hardware. If you're not using it, use it for something else. We know that Apple hardware and Mac OS virtualization is a thing. It has to be done on the Apple hardware. And another big thing is data center space constraints. Now with a lot of people creating cloud data centers, they've kind of moved off of their premise. The space has been reclaimed as office space. You need some small devices that aren't going to be obnoxiously loud to be able to virtualize. So when we take a look at all the various things, there's generally two reasons why people want to virtualize on Apple hardware. Number one is that they have to be able to do Mac OS, iOS, watchOS, tvOS, or Mac VDI. And the other is for R&D testing. So this is kind of an offshoot of the OS development, but as in anything, when you're going to do changes to a live production, you want to test and verify everything before you push out to 1,000 nodes and then find out, oops. So what are the limitations with going small? We've already talked about the fact that with the Mac Mini and with the Mac Pro 6.1, there are no internal PCIe slots that you can tap into. Thunderbolt is the only way to get PCIe functionality to external devices. We've talked about the RAM and the CPU limitations. You can max those out. Some people are comfortable doing that, some are not, because it may void the hardware warranty. There's storage limitations. You're stuck with a hard drive that's in there. The network connectivity is 1 or 2 1 gig ports, which is sometimes questionable. So what that presents is challenges for the administrator of how do I connect to my storage? How can I make a vSAN cluster? How can I gather the power of this and the hyperconverged capability of vSAN and run it off of these platforms? If I'm going to burn my internal drive to run ESX on, what are my options for additional storage, or do I just have to install onto a USB stick and run off of my data off of that internal drive? How can I expand behind the box? And up until now, there weren't that many for that. But then along came Thunderbolt, and back to Megan.
Yes, and really, as Eric talked about, as hosts became and they continue to become smaller, there's a true lack of expansion, such as those internal PCIe slots. And what Thunderbolt technology is going to do is it's going to fill that connectivity gap. So Thunderbolt was developed by Intel and Apple, and at the core, it's designed to allow those high-speed data transfers from today's latest hosts. And Thunderbolt's been around for a little less than 10 years, and we've seen 3 different versions of the technology. So the latest one that's out there is Thunderbolt 3, and it has doubled the speed from previous versions and has a transfer speed of 40 gig, which is going to translate into about 22 gig for data transfers. What Atto has done is we've taken our experience in providing high-speed connectivity like we would have for a traditional host with a PCIe slot, and we developed an all-in-one adapter that's designed specifically to work with the latest generation of hosts that have Thunderbolt on it. So what we have together is an extensive portfolio of products that allow access to both Thunderbolt 3 and Thunderbolt 2 hosts to storage protocols that include Fibre Channel, SAS, and Ethernet. And all of our products are designed to be low profile and they have a slim form factor. They're also going to be low power consumption and cooling efficient, which is going to make them great for a lot of different types of environments. The alternative to using something like an Atto Thunderlink Thunderbolt adapter is using an expansion chassis with an HBA or a NIC inside. Because it's not an all-in-one solution, a couple of downsides to this is it's going to take a longer time to assemble, deploy, and then also could take longer to troubleshoot because there's several different components involved. In addition, there's going to be a greater power draw, and it's going to take up more space than an all-in-one adapter, which is something that's really important when saving space is critical in a lot of these environments where we're seeing virtualization. Back to you, Eric.
Thank you. So what we've been able to do is generate VMware drivers for most of our technology, which allows our Thunderbolt adapters to be virtualized. We have placed our Thunderbolt 2 8 and 16 gig devices onto the VMware compatibility guide. We also have our Thunderbolt 3 12 gig SAS device on the compatibility guide. Our 10 gig and 40 gig Thunderbolt 2 and Thunderbolt 3 Ethernet devices will natively appear as either an Intel or a Mellanox device within VMware. That is based off the chipset that we partnered with for the development. So we know that VMware is by far the most popular virtualization software. So they had the problem. The problem wasn't solved by us. People for several years have been virtualizing the Mac Pro, virtualizing the Mac Mini, virtualizing the older Mac Pro 5.1s. We did not solve that problem. What we did was help create that solution to make these servers more versatile by expanding the storage capability and the networking capability beyond the box. So as you can see here, where we can fit into the mix, we can be Thunderbolt 3, Thunderbolt 2, 10 gig to provide faster connectivity. We can provide SAS connectivity. We could also be providing Fibre Channel connectivity to storage. In this particular case here, this was one of our demos at VMworld 2018, and we'd actually set up a vSAN cluster in this exact design right here. So what can people do with virtualized Macs? Virtual desktop infrastructure. Again, the ability to secure the devices, not allow them out, not have to take them out and be accessed remotely is critical from a security standpoint. Application development. Native tools for the Mac OS to develop for iOS, watchOS, tvOS, and develop within Mac OS itself is strongest within the Mac OS. Upgrade testing and rollout, you can even create a vSAN cluster if you would like. So application development, we know that you can create multiple different instances almost instantaneously of the Mac version from templates. This is very common in an R&D environment. Basically, whatever you want, you can create. The versatility is there. Once you get the Mac OS virtualized, once you get the hardware up and running, it's very, very simple, and this is absolutely nothing new. Again, the biggest shock to most people is that you actually can virtualize the Apple hardware. Desktop infrastructure, again, straightforward, very versatile. We're looking at pretty much the same modeling here, whether or not your role is to develop the apps or whether you just need the Mac OS for the day-to-day operations. It's going to be the same virtualizing infrastructure. And a shared content cloud for ad and web development. One of the caveats of virtualizing Macs right now is that PCIe pass-through is not allowed. Therefore, you cannot, as of right now, take advantage of the GPUs that the Mac Pro has or external GPUs. You cannot virtualize the fiber channel port and pass it through. So those are some of the limitations in virtualizing the Macs. However, low-end content creation, web creation, ad development, things like that are absolutely functions that can work within a virtualized infrastructure as it exists now. So we're going to do a very, very light overview on how to virtualize the Mac. We will be referencing a more comprehensive website attached to the Atto website, which will have some more step-by-step instructions detailed. But step one is thinking about things beforehand, and this is coming from a very personal set of oops that I did as I was working through virtualizing Macs. But after several stabs at it, after several iterations, starting with ESX55 and rolling through the current version of 6.7, sharing some of the things that we learned as we developed this concept. Number one was to back up the Mac OS. You're going to need that version of Mac OS unless you have plentiful source CDs and installation CDs available. You're going to basically need that Mac OS installer. So back it up, get it onto a CD. We've got plenty of steps in there for it. Creating that boot media ISO that you will probably need was the other consideration, and that was part of the steps that we created. So again, the media prep and to create the bootable Mac OS media, we've got a very, very detailed command line set of instructions that we have worked with Apple to develop, and those will be presented later on and on the website. The second thing that I typically do is use a USB stick to create the VMware boot image. That just makes it very, very easy, very versatile. I don't have to worry about burning an SSD or a hard drive, and I only need about 4 gigabits to do the typical install maximum. I've even done it as low as a 1 gig stick. You may need to add custom drivers to the ISO. This is another common caveat with virtualizing, especially a Mac Pro 6.1. Apple sometimes changes its SATA drivers. Usually people catch up with that and can post the information on the web. They've been very, very stable over the last year or so. And VMware also has a more generous set of drivers out there. One of the possible caveats is that you may have to change the VMware ISO so that the preferred VMK Linux kernel is actually enabled. With 6.5, that was disabled in preference of native drivers. Some of the versions of the Mac Pro 6.1 require the VMK Linux drivers to be enabled so that the SATA driver can be enabled. If you're going to be using purely external devices, and those are native, as with our Thunderlink fiber channel as an example, then you can skip that step, but most people like to prefer to install to the internal hard drive. Customizing the ISO is pretty straightforward. I tend not to use the internal native VMware tools. They are there. They will absolutely work, but you kind of have to have that one up and running first. I tend to use an older app that no longer works with Windows 10, but does work with Windows Server and an older version of Windows, as well as some other operating systems, but it was called the ESXi Customizer. Very easy, free tool to embed a VIB file into that ISO. As far as installing, almost nothing out of the ordinary. If you've turned on the VMK Linux kernel and you have embedded any drivers that you need, then it should be a straightforward install, just like any other server that you've done. Creating the VMs is very, very easy. Once you get used to the fact that you're pulling down the other for the guest operating system, and then you can select the Mac version that you wish to install, and installing the Mac OS. That sometimes is a little bit more of a challenge, getting it to boot from the CD. Sometimes it takes a couple of minutes before it wants to recognize it, but once you're there, it's easy, and then you can start cloning. So the key takeaways, you can virtualize your Mac Pro host, your Mac Mini host, and other microservers with ESXi, and Atto Thunderbolt adapters can provide you that storage connectivity. We have VMware ready VCG approved products. We can help support application development, VDI, cloud hosting, private clouds, whatever it is that you want to do. You know you're going to need to expand beyond the capability of those internal SSD drives, and we can help you achieve that. Our ThunderLink devices are built perfectly for smaller environments. Power consumption is low, and they can fit very, very easily into the typical data center. We even have a new rack appliance, which you can see on our website, which will allow you to, in a 1U form factor, I believe, rack up to 4 of our ThunderLink devices. So here are some resources. If you take a look at these, especially the bottom one, you should have most of our VMware solutions for the Thunderbolt there. The Mac Pro virtualization also will, I believe, link you to the specific steps that we discussed for that. Just briefly, this is our Thunderbolt certification matrix for the devices that are currently on the VCG. As I stated earlier, our 10 and 40 gig Thunderbolt 2, Thunderbolt 3 Ethernet devices appear natively as either an Intel or a Mellanox 10 or 40 device. We talked about needing the SATA drivers. Same thing for the NUC. Again, you're looking, when you're virtualizing a NUC, you want to take a look at the motherboard to see what's supported. We talked a little bit about adding the VMK Linux kernel. When it comes to the Mac OS, please consult with your Mac reseller or Apple to get the latest licensing requirements. We're not going to review them here. The EULA does tend to change, so what we say now might be different, but it's definitely a consideration. And we'd like to give a shout out to William Lamb, from who's a VMware employee, but on the side runs the site Virtually Ghetto. A lot of the groundbreaking was done by William for this topic. And just as I promised, here's a little teaser for the Mac Media Prep. Again, you'll find this on our website, so I would highly suggest that you go there.